This is the MAT Intermediate Algebra 1033 Final Exam Review. Problem number 1. Factor completely. 3x squared minus 19x minus 14. If we factor using the AC method, we multiply 3 times negative 14, we get negative 42. The factors of negative 42, 1 times 42, 2 times 21, 3 times 14, and 6 times 7. One is positive, one's negative. We then ask ourselves which pair subtracted will give us a negative 19. 2 and 21. Since 19 is negative, the bigger number carries the weight of our sign. The 21 will be negative. 2 is positive. Positive 2 times negative 21 is negative 42. Positive 2 times plus negative 21 will give us negative 19. We rewrite our polynomial as a 4-term polynomial. 3x squared plus 2x minus 21x minus 14. 4 terms factored by grouping. We cut our polynomial in half. We factor out the x on the left. X times 3x plus 2. On the right, we have a greatest common factor of negative 7. Negative 7 times 3x plus 2. Now we have a greatest common factor of 3x plus 2 multiplied by x minus 7. The answer for number 1 is A. Number 2, factor completely. 2rs plus 3rst minus 8r minus 12rt. Whenever we begin factoring, the first thing we always look for is there a greatest common factor? You notice there's a greatest common factor. The variable r is in all 4 terms. R times 2s plus 3st minus 8 minus 12t. We have a 4-term polynomial. We can factor it by grouping. We cut in half. On the left, there's a common factor of s times 2 plus 3t. On the right, common factor of negative 4 times 2 plus 3t. We have 2 plus 3t times s minus 4. And don't forget to bring down your GCF of r. Number 3, factor completely. 2x cubed plus 54. Again, we always look for our greatest common factor. We have a greatest common factor of 2. Factor out of 2, we have 2 times x cubed plus 27. We recognize that x cubed plus 27 is a sum of cubes. To factor a sum of cubes, we look at, recall a cubed plus b cubed is a plus b, a squared minus ab plus b squared. And also remember a cubed minus b cubed is a minus b, a squared plus ab plus b squared. They're factored very similar, it's just the signs that differ. To remember our signs, we think of the acronym SOAP. SOAP S is the same. So our first sign is always the same. If it's a cubed plus b cubed, it's going to be a plus b. A cubed minus b cubed, it's going to be a minus b. The O is for opposite. If it's plus, it's going to be a minus AB. If it's minus, it's going to be a plus AB. AP is always positive. So our last sign in front of our b squared, it's always going to be positive. Now x cubed plus 27, x is the term that's cubed, and to get 27, it's 3 that's cubed. So a is equal to x, and b is equal to 3. So if we have a cubed plus b cubed, it's a plus b, a squared minus ab plus b squared. So if we have 2 times x cubed plus 27, it's going to be x2 times x plus 3, x squared minus ab, a times b, which is 3x, and b squared, 3 squared, which is plus 9. Our answer for number 3 is D. Number 4. Determine the values of x for which x minus 4 over x squared minus 9 is undefined. Recall, whenever we have a denominator equal to 0, the term is undefined, the expression is undefined. So we want to find the values for x that would make the expression undefined, or the values of x that would make the denominator equal to 0. So in order to solve this, we set the denominator equal to 0 and solve. We do not have to worry about the numerator in this type of problem. So we have x squared minus 9 equals 0. You can solve this quadratic by factoring. X plus 3, x minus 3 equals 0. Set each factor equal to 0. So x equals negative 3, x equals positive 3. So if x were equal to negative 3, or x were equal to positive 3, the denominator would be equal to 0, which would make the expression undefined. The answer for number 4 is B. Number 5, we're going to divide 4x minus 16 over 5x plus 15 divided by 4 minus x, 2x plus 6. When we divide, what we do is we multiply by the reciprocal. We have 4x minus 16 over 5x plus 15 multiplied by 2x plus 6 over 4 minus x. Let me now factor everybody, all the expressions. 4 times x minus 4, 5 times x plus 3, 2 times x plus 3, and 4 minus x. We now see where there's a common factor in the numerator with the denominator. Any common factor in any numerator and any denominator can cancel out. We have x plus 3 and x plus 3. We have the x minus 4 and the 4 minus x. When we cancel these out, since they're opposites, we factor it as a negative 1. They're inverses of each other. X minus 4 and 4 minus x are inverses. When you cancel those out, it's a factor of negative 1. 4 times negative 1 times 2 gives us a negative 8. And on the denominator, we're left with a 5. Negative 8/5. The answer is C. Number 6, 2 over x squared minus 9 plus 5 over x squared minus x minus 12. In order to add or subtract rational expressions, we need to first find the common denominator. So to find the LCD, we're going to factor our denominators. X squared minus 9 factors to x plus 3, x minus 3. X squared minus x minus 12 factors to x plus 3, x minus 4. Now we look and say, what is our common denominator? The common denominator is x plus 3, x minus 3, x minus 4. So on the term on the left, to have the common denominator, what we need to do is we need to add the x minus 4 in both the denominator and the numerator. On the right, we need to add x minus 3 to our denominator and our numerator. 2 times x gives us 2x. 2 times negative 4 is minus 8, all over x plus 3, x minus 3, x minus 4. Plus 5 times x is 5x. 5 times negative 3 is negative 15, all over x plus 3, x minus 3, x minus 4. We combine like terms. 2x and 5x is 7x. We have negative 8 and negative 15 is a negative 23, all over x plus 3, x minus 3, x minus 4. The answer for number 6 is E. Number 7, simplify the complex fraction. 3 plus 7 over x, all over 1 over xy, plus 2 over y. We can first put a denominator of 1 over 3, and we want to find the LCD, and then multiply all terms by the LCD. So our common denominator for 1, for x, for xy, and for y is xy. We're now going to multiply all terms by xy. So you have xy times 3, or 3 over 1, plus xy times 7 over x, xy times 1 over xy, plus xy times y, 2 over y. When we multiply by the LCD, we want to get rid of the denominators for all of our terms. X times y times 3 is 3xy. The x's cancel out here. We have y times 7 is plus 7y. In the denominator, the xy's crossed off. We have 1, and y's crossed off. X times 2 is 2x. The answer for number 7 is B. Number 8, we're going to solve the rational equation 4x plus 1 over 4 minus 2x plus 3 over 3 equals 7 over 12. When we solve rational equations, we first want to look if there's any restrictions. Since we have constants in all of our denominators, there's not going to be any restricted values for x. We now multiply all terms by the LCD. Our LCD for 3, 4, and 12 is 12. So we multiply 12 times 4x plus 1 over 4 minus 12 times 2x plus 3 over 3 equals 12 times 7 over 12. 4 goes into 4 one time, goes into 12 three times. We have 3 times 4x plus 1. 3 into 3 once, 3 into 12 4 times. We have a negative 4 times 2x plus 3 equals 12 into 12 once and 12 into 12 once equals 7. To solve, we distribute. 3 times 4x is 12x. 3 times 1 is 3. Negative 4 times 2x is negative 8x. Negative 4 times 3 is negative 12 equals 7. Combine our like terms. 12x and negative 8x is 4x. 3 and a negative 12 is negative 9 equals 7. Add 9 to both sides. X equals 16. Divide both sides by 4. X equals 4. The answer for number 8 is A. Number 9. Write the equivalent in radical form. 27 to the negative 2/3 power. First, recall, whenever we have something to a negative exponent, to make the exponent positive, we take its reciprocal. It will be 1 over a to the n. Also recall, anything to a fractional exponent, the denominator becomes our index. The base stays the base, and the base is raised to the numerator exponent, or can be written as the index a all to the numerator power. So first we need to convert 27 to the negative 2/3 power with a positive exponent, so it'll be 1 over 27 to the 2/3 power. The denominator again is our index, so the cube root of 27, and again the numerator is what the base is raised to, squared. Number 9, the answer is B. Number 10, we want to simplify. Square root of 18. Square root of 8 plus the square root of 18. In order to add or subtract radicals, the number underneath the radical, the radicand, has to be the same. We first need to simplify our radicals. We can simplify square root of 8 to square root of 4 times the square root of 2, or 2 square root of 2. The square root of 18 can be simplified to the square root of 9 square root of 2, or 3 square root of 2. 2 square root of 2 plus 3 square root of 2 is 5 square root of 2. The answer for number 10 is C. Number 11, the square root of 6 minus 2, the square root of 6 plus 2. Multiply binomials. You guys may recall using FOIL. The first, when you distribute the first terms, the outer terms, the inner terms, and the last. Square root of 6 times the square root of 6 is the square root of 36. Square root of 6 times 2 is positive 2 square root of 6. Negative 2 square root of 6 is negative 2 square root of 6, and negative 2 times positive 2 is negative 4. Square root of 36 is 6. 2 square root of 6 minus 2 square root of 6, they cancel out. Minus 4 is 2. The answer is A. Also recall, when multiplying by a conjugate, you can multiply the first terms times the last terms, because if you recognize, the middle terms are going to cross off. So again, square root of 6 times the square root of 6 is the square root of 36, or it's 6. Negative 2 times positive 2 is negative 4, minus 4. 6 minus 4 is 2. Number 12, rationalize the denominator. 5 over 8 minus the square root of 3. To rationalize the denominator of a binomial, we multiply by the conjugate. We multiply by 8 plus the square root of 3. 8 plus the square root of 3. The denominator, 8 minus the square root of 3 times 8 plus the square root of 3. We just reviewed multiplying by the conjugate. Multiply our first terms. 8 times 8 is 64. And our last, negative square root of 3 times positive square root of 3 is negative square root of 9. Or 64 minus 3 is 61. So our denominator is 61. The numerator, we have 5 times 8 plus radical 3. The answer is C. Number 13. Solve for x. X squared minus 2x equals 8. We recognize this is a quadratic. We can solve either by factoring, completing the square, square root property, or using the quadratic formula. If we look ahead at the answers, we notice that we have radicals and radicals in our answers, so possibly this expression may not be factorable. So let's try completing the squares. We have a coefficient of 1. We have a b term of 2. So we have x squared minus 2x equals 8. To complete the square, we take 1/2 of the negative 2, which is negative 1, and negative 1 squared is 1. So if we add 1 to both sides, you have x minus 1 quantity squared equals 9. Take the square root of both sides, x minus 1 squared. On the right, plus or minus the square root of 9, you have x minus 1 equals plus or minus 3, or x minus 1 equals 3, x minus 1 equals negative 3. X equals 4, x equals negative 2. So our answer is B. Knowing that we have two integers, we also could have factored this. Look again at the problem. We have x squared minus 2x equals 8. To factor, we set it equal to 0. X squared minus 2x minus 8 equals 0. Factor x squared minus 2x minus 8. We have x plus 2, x minus 4 equals 0. Set each factor equal to 0. X plus 2 equals 0. X minus 4 equals 0. X equals negative 2. X equals 4. So again, we have the same answers. Number 14. (2x squared plus 4x equals 9x plus 18). Recognize we have a quadratic with the x squared term. Let's put all our terms on one side. Subtract 9x. So you have 2x squared minus 5x equals 18. Set it equal to 0. Subtract 18 on both sides. 2x squared minus 5x. 2x squared minus 5x minus 18 equals 0. We factor 2 times negative 18, negative 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. Which pair? Subtracted will give us a 5, the 9 and the 4. And positive 4, negative 9. So we have 2x squared plus 4x minus 9x minus 18 equals 0. 4x minus 9x is a negative 5x. Cut our polynomial in half. 2x times x plus 4. Factor out negative 9. Excuse me, 2x times x plus 2. Negative 9 times x plus 2 equals 0. X plus 2, 2x minus 9 equals 0. Set each factor equal to 0. X plus 2 equals 0. 2x minus 9 equals 0. Subtract 2 on both sides. You have x equals negative 2. Add 9 to x equals 9 and divide by 2. X equals 9 over 2. The answer for number 14 is A. Number 15. Eight x to the 4th minus 18x cubed minus 5x squared equals 0. We have a common factor of x squared times 8x squared minus 18x minus 5 equals 0. We continue factoring. 8 times negative 5 is negative 40. 1 times 40, 2 times 20, 4 times 10, 5 times 8. Which pair subtracted will give us a negative 18? So we have negative 20 times positive 2 is negative 20 times positive 2 is negative 40. Negative 20 plus a positive 2 is a negative 18. So we have 8x squared plus 2x minus 20x minus 5. Cut the polynomial in half. Common factor 2x times 4x plus 1. Negative 5. 4x plus 1. 4x plus 1. 2x minus 5. And bring down the GCF of x squared equals 0. Now that we have it factored, we set each factor equal to 0. X squared equals 0. 4x plus 1 equals 0. 2x minus 5 equals 0. We solve. X equals 0. Subtract 1. And divide by 4. X is negative 1 over 4. Add 5. Divide by 2. X equals 5 halves. So you have x equals 0, x equals negative 1/4, and x equals 5 over 2. The answer for number 15 is D. Number 16, find slope. Been given 2 points. Negative 3, 2, and 5, negative 5. Formula for slope. Slope or m, is equal to the difference in y's, change in the y direction, over the difference in x is the change in the x direction. Points are labeled x, y. X, y, x, y. To distinguish point 1 and point 2, the first point we'll call point 1, so this could be x1, y1 as the coordinates. Second point will have coordinates x2, y2. x2 is -5. -5 subtract 2. x2 is 5 minus x1 is -3. -5 minus 2 is -7. -5 minus 3, subtract a negative, is a positive. 5 plus 3 is 8. Our slope is equal to -7/8. The answer for number 16 is E. Number 17, find the slope of a line that is perpendicular to the line 4x plus 3y equals -6. If we know the slope of the given line, we know our perpendicular slopes are opposites and reciprocals. So let's first find the slope of this line. To find the slope, we put the equation in slope-intercept form. Subtract 4x on both sides. 3y is equal to -4x plus 4x minus 6. Divide by 3. Y is equal to -4/3 x minus 2. The slope of this line is -4/3. If we recall in slope-intercept form, the m is the slope, and just recall the b is your y-intercept. Perpendicular slopes are opposite reciprocals. So if the slope is -4/3, the opposite of a negative would be positive. The reciprocal of 4/3 would be 3/4. So the perpendicular slope is equal to 3/4. Your answer for number 17 is A. Number 18. We have to find the slope that's parallel to the line 2x minus 6y equals 8. Lines that are parallel have the same slope. So let's first find the slope of the line 2x minus 6y equals 8. Put it in slope-intercept form. We subtract 2x on both sides. -6y equals -2x plus 8. Divide by -6. If y equals a negative over negative is a positive, 2/6 is 1/3 x. 8/6 is -4/3. My slope for this line is 1/3. Lines that are parallel have the same slope, so the parallel slope is also equal to 1/3. Number 18, the answer is A. Number 19, determine whether the lines 3x minus 2y equals 6 and 2x minus 3y equals 6. If their lines are parallel, perpendicular, or neither, again we're going to compare our slopes. We're going to write our equations in slope-intercept form. Y equals mx plus b. On the left, 3x minus 2y equals 6. Subtract 3x on both sides to isolate the y. So negative 2y, negative 3x plus 6. Divide by negative 2. You have y equals a negative over a negative. It's a positive. 3/2 x, positive 6 divided by negative 2 is negative 3. The slope of this line is equal to 3/2. On the right, 2x minus 3y equals 6. Subtract 2x on both sides. Negative 3y is negative 2x plus 6. Divide by negative 3. Y equals a negative over a negative is a positive. 2/3 x minus 2. So for this line, our slope is 2/3. So if the lines are parallel, they have the same slope. The slopes for these two lines are not the same. They're reciprocals, but they're not the same, so they're not parallel. In order for lines to be perpendicular, not only do they need to be reciprocals, but also opposite signs. So they're not perpendicular. So the answer for number 19 is neither, which is C. They're not perpendicular and they're not parallel. Number 20 asks us, which of the following is the graph of 3x plus 4y equals 12? To determine which of the graphs would match this equation, we can look at several things. First, one of the things we can look up is the intercepts. How can we find the intercepts of this equation? Well, if we plug in 0 for y, we can find our x-intercept. If we plug in 0 for x, we can find our y-intercept. Plugging in 0 for y, 3x plus 4 times 0 equals 12. 3x equals 12. Divide by 3. X equals 4. Our x-intercept is at the point 4, 0. To find the y-intercept, we plug in 0 for x. 3 times 0 plus 4y equals 12. 4y is 12. Divide by 4. Y equals 3. 0, 3. So looking at these graphs, which one has intercepts of 4, 0 and 0, 3? For number 20, it's graph B. 4, 0 and 0, 3. The x-intercept and my y-intercept. Number 21. Find the x-intercept for 4x minus 3y equals negative 12. To find the x-intercept, we plug y for 0. 4x minus 3 times 0 equals negative 12. 4x equals negative 12. Divide by 4. X equals negative 3. So negative 3, 0 is the x-intercept, or the coordinate is x equals negative 3. Y would be 0. So for 21, the answer is C. Number 22, to find the y-intercept. You plug in 0 for x to find the y-intercept. Y equals 6, divide by 2, y equals 3. So the point 0, 3 is the y-intercept. For 22, the answer is D. Y-intercept is 3. Number 23, we're going to look back at our graphs. And 24. For 23, we're looking for the graph for x equals -3. X equals -3, hopefully you recall, x equals -3 is a vertical line. All of the x coordinates are going to be equal to -3. It's the y's that change. So, for example, x equals -3. You have a chart. -3. We can have -3, 2, -3, 0, -3, -1, and so on. So vertical line showing x equals -3 is choice B. For the line y equals -3, this is a horizontal line going through -3. So the y coordinate is always going to be -3, 5, -3, 2, -3, 0, -3, 2, -2, -3. 24, it's choice A. Here's the line, the horizontal line going through -3. For number 23, the vertical line going through x equals -3. Solve the rational equation. Solve the rational equation. We're first going to look for our restrictions. The variables, the denominators with variables, we set equal to 0. So if x were equal to 0, that would be a restricted value. We also want to find our LCD. Our LCD would be x squared. So you first multiply all terms by the LCD to clear fractions. So you have x squared times 3 over x squared plus x squared 2 over x equals x squared times 1. The x squareds cross off, you have 3. X goes in x once, x squared and x times, so you have x times 2, which is 2x equals x squared. You have a quadratic equation. We'll put all terms to one side, set equal to 0. Subtract 2x, subtract 3, subtract 2x, subtract 3. So you have x squared minus 2x minus 3 equals 0. We can factor. X plus 1, x minus 3 equals 0. X plus 1 equals 0. X minus 3 equals 0. Subtract 1, x equals -1. Add 3, x equals 3. So for number 25, -1, 3, your answer is D. Number 26, y to the 1/3 power, y to the 2/5 power, all over y. When you hopefully recall, when you multiply, bases are the same, you add your exponents. So we're first going to add 1/3 plus 2/5. We have a common denominator of 15. Multiply by 5. 5 over 15 is 3. Plus 6 over 15 is 11 over 15. So we have y to the 11 over 15th power over y, or y to the 1. When we divide, we subtract exponents. (11 over 15 minus 1, which is the same as 15 over 15, is negative 4 over 15. So y to the negative 4 over 15. Recall, anything to a negative exponent, we take its reciprocal, 1 over a to the end. So the answer is going to be 1 over y to the 4 over 15th power. The answer for number 26 is D. Again, multiply, same basis, you add the exponents. Divide, same basis, you subtract the exponents. Number 27. X plus 5 squared equals 3. Solving a quadratic, it's set up in the to use the square root property. You take the square root of both sides. Square root of x plus 5 quantity squared. Take the square root of 3 plus or minus the square root of 3. The square root of a term that's squared, they're opposite operations, they cancel each other out. You have x plus 5 equals plus or minus radical 3. To solve for x, you subtract 5 on both sides. X equals negative 5 plus or minus square root of 3. Or it can be written as x equals negative 5 plus radical 3. X equals negative 5 minus radical 3. The answer for number 27 is D. Number 28, solve the system. X plus y equals negative 5, negative 2x plus y equals 1. We're going to solve for y. Solve the system for y. So if we're going to solve for the y, we're going to cancel out our x's. We use the addition elimination method. If this is a negative 2x, if this was a positive 2x, the x variable would cancel out. So we're going to multiply the top equation by 2. 2 times x plus y equals negative 5. So you have 2x plus 2y equals negative 10. The bottom equation will stay the same. Negative 2x plus y equals 1. The x's cancel out. 2y and y is 3y equals negative 9. Divide by 3. Y equals negative 3. The answer for number 28 is B. You also could have used the substitution method. I said x plus y equals -5, or x is negative y minus 5. Substitute your first equation into your second equation. -2 times -y minus 5 plus y equals 1. -2 times -y is 2y. -2 times -5 is positive 10, plus y equals 1. Combine like terms. 3y plus 10 equals 1, minus 10. 3y equals -9. Divide by 3, y equals -3. So either method works. 29 is a word problem. A rectangular tabletop is 2 feet longer than it is wide. I like to draw my picture of a rectangular tabletop. It's 2 feet longer than it is wide, and the area is 24 square feet. So we know the area is 24 feet squared, and we also recall that length times width equals area. If it's 2 feet longer than it is wide, or width, it can be x, and the length is 2 feet longer, or 2 feet meaning adding 2, so it would be x plus 2. To write the equation to solve this problem, and then to solve it, we recall length. Area is length times width is area. So we would say x times x plus 2 equals area, which is 24. To solve the problem, x times x is x squared, x times 2 is 2x equals 24. Subtract 24 on both sides. We have x squared plus 2x minus 24 equals 0. Solve by factoring. X plus 6, x minus 4 equals 0. X plus 6 equals 0. X minus 4 equals 0. Subtract 6. X equals -6. X equals 4. Substitute in -6 for value of x. We would have a width of -6 and a length of -4. Well, we can't have a negative value for our dimension. So we know that x equals -6 is not the correct answer. As far as x equals 4, the width of 4 and the length, which is 4 plus 2 is 6, it's 2 feet longer, and if we check the area, 4 times 6 is 24, or 4 feet times 6 feet is 24 feet squared. So the answer for 29 is A. For number 30, what number must be added to x squared plus 20x to form a perfect square trinomial? To solve this, you take the number in front of the x, the b, you do 1/2 of b, then square the result. So 1/2 of 20 equals 10. 10 squared is 100. So 100 is what is added. The answer for number 30 is C. 31. Solve the rational equation. X over x minus 3 plus 4 over x plus 3 equals 18 over x squared minus 9. We want to first start off by doing two things. We want to find our restrictions and find our common denominator. So to factor, we have x plus 3, x minus 3. So our LCD is x plus 3, x minus 3. Our restrictions, x minus 3 equals 0 and x plus 3 equals 0. So x equals 3 is a restricted value and x equals negative 3 is a restricted value. After we solve this problem, if the value for x is equal to either 3 or negative 3, since those are restricted values, they cannot be the true solution to this problem. Now that we know our LCD, we're going to multiply all terms by the LCD. X plus 3 times x minus 3 times x over x minus 3 plus x plus 3 times x minus 3 times 4 over x plus 3 equals x plus 3, x minus 3 times 18 over, and I'm going to keep it factored so it's easy to cancel out, x minus 3. The x minus 3 cancels out. I'm left with x times x plus 3. The x plus 3 cancels out. I'm left with 4 times x minus 3 equals x plus 3 crosses off, x minus 3 crosses off equals 18. I solve x times x is x squared, x times 3 is 3x, distribute 4 times x is 4x, 4 times negative 3 is negative 12 equals 18. Combine like terms, x squared plus 7x minus 12 equals 18. Set it equal to 0, subtract 18 on both sides. X squared plus 7x minus 30 equals 0. I now factor what two numbers multiplied together give me 30, but subtracted will give me a 7. We have x plus x minus. Well, I know factors of 30 include 1 times 30, 2 times 15, 3 times 10, and 5 times 6. 3 times 10 is 30. Positive 3 times a negative 10 would be a negative 30. Positive 3 minus 10 will give me a so negative 3 and a positive 10 will give me a positive 7. So we have x minus 3, x plus 10 equals 0. Set each factor equal to 0. X minus 3 equals 0. X plus 10 equals 0. Add 3 to both sides. X equals 3. Subtract 10 on both sides. X equals negative 10. You see, the value of x equals 3 is a restricted value. Since this is a restricted value, that's not our answer. The only answer for this problem is x equals negative 10. X equals negative 10 choice is letter D. Number 32, simplify the rational expression. For x squared minus 25y squared over 10y minus 4x. To simplify, multiply or divide, we must factor first before we cancel. So we don't just start canceling off like terms. You have to factor first before you cancel. So we can't cross off these 4x and the 4x squared. We can't simplify those. You have to factor first. So to factor the numerator, it's a difference of squares. We have 2x plus 5y, 2x minus 5y. And denominator has a common factor of 2. 2 times 5y minus 2x. 2x minus 5y and 5y minus 2x, they're opposites. When you cross them off, you have a factor of -1. The answer is negative 2x plus 5y all over 2. The answer for 32 is A. (33) x squared plus 6x equals -11. The problem set up, we can easily complete the squares. The coefficient in front of x squared is 1. Coefficient in front of the x is an even number. It's easy to complete the squares. You can take 1/2 of 6 is 3, and 3 squared will give me 9. So we have x squared plus 6x plus 9 equals -11 plus 9. I simplify the right, factor the left. I have x plus 3 squared equals -2. Take the square root of both sides. Square root of x plus 3 quantity squared. On the right, take the square root plus or minus radical -2. Simplify the left. We have x plus 3 equals plus or minus square root of -2 is the square root of -1 times square root of 2. Square root of -1 is I radical 2. So the right simplifies to I radical 2. Subtract 3 on both sides. We have x equals -3 plus or minus I radical 2. The answer for 33 is C. Number 34, another quadratic equation. Let's solve this one using the quadratic formula. 5x squared minus 3x plus 4 equals 0. The quadratic equation, x equals opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. In order to solve using the quadratic formula, we must be in standard form. ax squared plus bx plus c equals 0. We are in standard form. A is equal to 5, b is equal to -3, c is equal to 4. Let's also write down the opposite of b, or negative b, is going to equal to 3. If b is equal to -3, the opposite of b is going to be positive 3. Let's plug all our numbers into the formula. X equals the opposite of b, which is 3, plus or minus the square root of b squared, -3 squared, minus 4 times a, which is 5, times c, which is 4, all divided by 2 times 5. X equals 3, plus or minus the square root of 9. -4 times 5 times 4 is -80, all divided by 10. X equals 3, plus or minus the square root of -71 over 10. We can't simplify 71, but we can simplify the square root of -71 as square root of -1 times the square root of 71. Square root of negative 1 is I. Square root of 71 is still the square root of 71. So our answer would be x equals 3 plus or minus I radical 71 all over 10. The answer for 34 is E. Number 35, the cube root of 250 x to the 7th y to the 14th. Let's recall our numbers are perfect cubes. Well, I know 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, and so on. Looking at 250, we notice that 250 is not a perfect cube root. However, 125 is a perfect cube root, and it's also a factor of 250. So let's break up the 250. Say the cube root of 250 is 125 times 2. So the cube root of 125, the cube root of 2 is going to give us the 250. Cube root of x to the 7th. Well, 7 is not divisible by 3 evenly, but we know the cube root of x to the 6th and the cube root of x. Also, y to the 14th. 14 is not divisible by 3, but 12 is. The cube root of y to the 12th and the cube root of y squared. Anything that's a perfect cube root will come out of the radical sign. Cube root of 125 is 5. The cube root of 2 will stay under the radical. Cube root of x to the 6th, 6 divided by 3 will give me x squared. The cube root of x stays under the radical. The cube root of y to the 12th, 12 divided by 3 is y to the 4th. Cube root of y squared, we can't simplify it, stays under the radical. So our final answer is 5x squared, y to the 4th, cube root of 2x y squared. The answer for number 35 is D. Number 36, 5 over 4x squared minus 2 over 3x. Recall when we add or subtract rational expressions, add and subtract, we must have a common denominator. The common denominator for number 36, LCD, is 12x squared. In order to have our denominators the same, if I multiply the left by 3, I'll have a 12x squared. If I multiply 3 in the denominator, I must multiply by 3 in the numerator. On the right, if I multiply by 4x in the denominator, I'd have to also multiply by 4x in my numerator. 3 times 5 is 15, all over 12x squared. 2 times 4x is 8x. All over 12x squared. Denominators are the same. I bring it across, 12x squared. I have 15 minus 8x. They're not like terms, so I leave it as is. 15 minus 8x over 12x squared. The answer for 36 is A. 37. Denominators are the same. If the denominators are the same, I just bring it across. X minus 3. For my numerator, I have to distribute the subtraction. So it will be negative 13, and a negative times a negative minus a negative 3x will be a positive 3x. I combine my like terms. 7x plus 3x will give me 10x. I have a negative 4 and a negative 13 will give me minus 17. 10x minus 17 all over x minus 3. The answer for 37 is B. Number 38. Three times radical 54 plus 2 times radical 24. We recall we cannot add or subtract radicals unless the radicand, the number under the radical sign, is the same. Let's simplify. 54. Well, the square root of 9 times the square root of 6. 9 times 6 is 54. 9 is a perfect square root. 3 times 3, radical 6, or 9, radical 6. 24 is 4 times 6. Square root of 4 times the square root of 6 is the square root of 24. 2 times 2, radical 6, is 4 radical 6. We can now combine them. We can add them. 9 radical 6 plus 4 radical 6 is 13 radical 6. The answer for number 38 is A. Number 39. To rationalize the denominator, we want to get rid of our radical. If we multiply it by the square root of 3, the radical will remove our radical sign in the denominator. Also, we recall multiplying by a factor of 1 does not change the value of our term. So if I multiply by square root of 3 over square root of 3, I'm not changing the value. I'm multiplying it by 1, but I'm also allowing myself to get rid of the radical in the denominator. So square root of 3 over square root of 3, the numerator becomes 6 square root of 3. The denominator becomes 5 times the square root of 9, or 6 radical 3 over 5 times 3, which is just 6 radical 3 over 15. We can now simplify. 3 goes into 6 2 times, 3 goes into 15 5 times. The answer is 2 radical 3 all over 5. The answer for 39 is E. X to the 4th times x cubed all to the 3/2 power. Again, when we multiply, we recall, as long as the base is the same, we add the exponents. So this becomes x to the 7th to the 3/2 power. When we raise a power to a power, we multiply the exponents. So we have 7 over 1 times 3 over 2 is just 21 over 2. The answer for 40 is x to the 21 over 2 power. The answer for number 40 is A.